So guys, it's just day 73 now of programming every day. It's currently like 2 a.m. I just can't sleep, so I figured I'd just stay up and learn assembly. Yeah, let's get started. So we left off with learning that the EAX register is kind of like, or the EAX4, if we set EAX to 4, it's the write function. And if we set EBX to 1, that's the standard output. And then we put it to ECH register. But yeah. Pushing basically does this. What about maybe like this? No. Boy, I wanted to do this. Global. Jeez. Home. End. Start. Jeez, the EAX. Move EAX to 1 or to 4. Move EDX to 1. ECX to our variable, so we'll do find byte. Oh my gosh, I always forgot. Zero XA. So I was kind of close. See to message and then move E. Wait. Yeah. Wait. ECX, EDX. So it's D. Yeah, I was right. And X length. So then we'll define length down here. Define byte or equal $/message. And then we'll call to the standard, or an interrupt 0x80. I think it's EDX. Wait. EAX to 1. ALS to 1. EAX to 1. And then interrupt 80. Linker. Wait. Make file. Let's see. That's not what I want. I want to know how to compile. If I do something like oh. Oh. Dash F elf. Actually, we just copy the command. We need the linker command. Elf a.asm and run that. This should just print to the standard output. I don't. Okay. Global. Move EAX 4. Move EBX 1. Move ECX message. Move EDX length, call an interrupt, move a EBX to 1, or EAX to 1, and then call another interrupt. Oh, right, I forgot to message equals defined by hello world 0x like that. Length equals equal $sign of message. So this whole script right here should, yeah, there we go. I'm too good. I wonder, could we just call a syscall? I'm wondering. Does this work the same? Illegal instruction. Uh-oh. My bad, bro. My bad, bro. Standard. Okay. Okay. So clearly that's not God, this video is long. So wait, if I were to start in here, do like increment hello. in assembly and store value. These lines. So like 200, right? And then XOR EAX, right? Does that work? Okay, so we know how to add. EAX would equal AEX. Okay. Okay. So then what if I do move hello EAX? See, it doesn't like that. I don't get this. So this clears the value in the register. This subtracts 200. So the value in EAX should be negative 100. Oh. So what are we talking about? Let's move this down to what? Okay. So EAX D word pointer X rip. Okay. If I'm being honest, none of this shit's making sense. I want it to be so I could create a variable. Maybe it's. What was in here? Thought 0, 4. My program did not like that. Let's try to make a simple game. Random in assembly. Oh, Jesus. Okay, wait. Okay, wait, let's look. So, just here, let me do it in C real quick. Time H. Turn 0. Modulus 2. Yeah, that's how you do it in C. Let's just paste it into here. Oh my gosh. Okay. All this code right here is all this assembly code. Just for a random address p if have to put my tech in. Tech in. See, that's dope. Now if you if you were to put that, okay, wait, let's just do this. Void p. Okay. So we p, and then what if we do if x equals p? P. Dang it. I'm running out of variables. L. Same Python. Okay. Keyword pointer. So if I were to do let's remove all this. Let's see, so move (16). Why are we subtracting? What did I do in my code? Oh, so we compare the two. Now I don't know why. (16-bit minus 4). Oh, I get it. But how would you? But EAX isn't even defined yet. Oh no. Okay, so this would be a variable. RBP minus 8, 2. Oh, so you can store, wait, you can store local variables. Okay, so then, compare EAX to pointer, right? RBP minus 8. And then if that's true, we, oh. I think this is if it equals each other. Then dot P, and then we come down here and we call dot P. Or could we just do P? Else jump to LP. LP. Then we move EAX to 4 and move EBX to 1, move ECX to our message, or so if we come down here, or new, define byte, equals 0 0xa new length equals $, dash new message 0xa. And then we call our new message and then move into EDX our message length. So end length. I'm trying to think of what else. And then just interrupt. Then LP will just still remove from that, move EAX to 4, move EBX to 1, move I spelled move ECX to our other, or EDX to our other L, and then interrupt. And then we'll define our other variable. 0xa equals this will be other. Okay. God, all that assembly for an if-else statement. Jeez. And it doesn't even work. It's not a NASM keyword. I guess we could just do move into RBP, then move into RSP. Let's remove all this. Right. And then get rid of this. Get rid of this. RBP. Compared it to RSP. Wait. 39. Oh my gosh, what? Apparently we're doing assembly in 32-bit, so E and like this. Bro, it's not even interrupt. Let's just get rid of this. Equals, or I guess it'd be the other way around. So it'd be jump LP and P. Okay, so we got these figured out. Kinda. So And instead of this, we'll set this to 2. See what happens. Should equal. Yeah. Okay. String defined by 100. Okay, wait. So right here is a comparative statement. This is if it's true, if not, or else. I guess you jump to that. So okay, so that's that. We need to get the value from string. So move e, or it's eax to 3, and then move ebx to 0, right? And then move ecx to string, I believe. Let's try it. Oh, I forgot to do a interrupt. Zero x 80. Make define byte. But I thought if I guess we can't take input, guys. Can you believe that somebody made a whole video game, the roller coaster tycoon, with this? Isn't that nuts? Somebody wrote this in assembly code. Now that's pretty crazy. Yeah, it's pretty crazy. So JNE is if, jump is that, and we're gonna have to have functions for each, which is kind of crazy. And I wonder, does it run everything underneath? Would you hit it with the and then you do the return? Do you hit it with the return? You don't hit it with the return. Oh shoot. Make it a little bit easier on us. Then what does return do? Int 0x 80 and then return? Right, we have to hit the interrupt. make. Okay. So get this. It's seg faulting, but I think because it's EAXS2. Seg fault at 2. Yeah, that's just not, a value. How would this be? Would this be like if you were to create a function and it compares both of them to see if they're true? It's like it will compare. Let's also get rid of the string. Um, there's error in the make file. Wow. Okay, so so cool. The and instruction. These are all 16-bit assembly. So, x86. Move REX to 4. And where'd my phone go? Where'd it go? I just had it. Hold guys, I gotta go to the restroom. I'll be right back. Sorry about that, guys. Had to pee. So these are two common patterns for a while loop. Because I'm going down the rabbit hole right now. God, it's like... Hold up. Okay, now. Let me just remove a.asm. Right? Global start RAX EAX1 comp EAX EX to 2, JME L JMP P L P so down here define byte world 0x e 0x a ml equals okay, so move, or actually no, EAX is for E, okay, wait, XOR EAX, move EAX, 4, move EDX to 1, move ECX to message, move EBX to ML, and then we call it interrupt, and then we move EAX 1 to exit the program, and then we call our interrupt. So XOR EAX, move EAX to 4, move, maybe not, maybe we don't even have to do this. Let me just comment it out. I'm gonna do that. Okay, move EDX to 1, move ECX. What should be like else. EL. Interrupt 0x80. Move EAX to 1, move, or interrupt. And then down here we define else db not hello world, and then the 0xa, and then el equals else. Instruction expected 16. Oh. So if it equals 2, say 1, why is it not? That's why. There we go. So these registers right here, this is the... I can't believe I didn't like know this, and it's not that hard. It's just, you know, yeah. So, okay, so RBX, JLE, exit loop, exit. What couldn't you do like? Okay, so that's cool. So say I set EAX to 1. But then would it be created? So if it be a start loop. So if this is true, we jump to the start loop and it compares. We also have to add an exit thing here. Interrupt 0x, or actually move EAX to 1, and then interrupt. So if it doesn't equal, then move EAX. Or actually, we could do any other register. No, actually, let's just see if this runs. Okay, wait. Okay, wait. So see, we can't jump in the middle of a thing because it would just... It would just exit our program. So yeah, instead of this, instead of just having exit like this, we could just jump. We could just, instead of jumping to exit, we could just jump to L. Wow, that's so cool. Okay, so this is the while loop. ECX. Does this work too? Wow. Yeah, believe it or not, assembly's not that hard. I know it sounds crazy. And that's a crazy thing to say. Because people say assembly's so hard, but I like assembly. I like it a lot. Beautiful language. Very simple. Okay. Back to it. See, that's really cool. So, let's make a note of this. While loop. Compares if not true keeps going, adds 1. I guess this could also be a for loop. For loop x86 for edges. What does J and Z mean? Jump. Decrement. Do stuff. Okay. Okay, it's making sense. So we got the for loop, we got the variables, reruns. So we got the variables, we got the, okay, let's look up. They done got a raise? What? Okay, wait, this is dope. Move pointer to the next element. Interesting. Interesting. Okay. So let's try to make something. Simple program. Now I can't even imagine trying to oh, we don't want no C. So we don't lag my computer. So let's get rid of all this. Not ls. Let me think. What was I about to do? I was about to create a word pointer. I guess you have to define how many bytes. I think each register has a certain amount of bytes that I could use. Okay, let's do the string. I print F. Or not decimal, character. Why is this wrong? And then lists 1, so it should print out 2. So if I do something like this, to n, eight, wait, so how would this, okay, so a lot of it is just, so the, see, that's annoying, so you have to create, right? Oh, wait. Can you just declare variables like this? So if I did like, let's do it in student start, move sum to, I can't do that. Is sum defined? Oh, it is. Sum find db0. Interesting. So we can't add to the sum for some reason. Store result in sum. Interesting. Okay, I kind of want to see how to do this. So if it doesn't equal 9, but if it equals 2, and then 9, it should equal the same. Wow. Not name. So you do and EAA. Wow, and then you'd hit it with the 1, it should print out something else. Wow. It's kind of easy. It really is kind of easy once you get used to it. Okay. So here's where it's almost 4 o'clock. I have work in like 4 hours. What's the test operator? Data definition directives could also be used for one-dimensional array. Let's define one-dimensional array of numbers. So you define that. Okay, now how would you... Oh, you do it like that. And that's it. That's literally it. I mean, you know, like most of these, all I need to know is lists. I got for loops, while loops, um, like it's not that hard. Oh my gosh, it's really not that hard. So if I'm feeling a little bit tired, I might go to bed. Would this technically count as like I spent almost 3 or 4 hours coding today? Should that be a crime? I don't think it should be. But we learned so much today. We learned pretty much like the basics of the assembly language. Wow. Wow. File management. No, let's hear this one. Or let's see this one. Oh my gosh. Hold on, I gotta go pee again. I don't know why I keep having to go pee. I drink a lot of water. Okay. Oh. Oh. Let's move my camera a little bit this way. There you go. Okay, so, you know, assembly isn't too hard after taking a bathroom break. Now this might be and why would you need to know recursion? You literally just, you call it again, and that would multiply BL AL AX equals AL times BL decrement call proct fact. See, every time I do the or wait, would I have to call into AEX, or would I do AX of 1, right? And then would I hit return? No, let's just play it safe. Okay, so let's kind of display our skills here. Okay, let's copy all this data. Okay. I'll use that as a reference, but okay, so starting out, global. Start. What should we do first? Okay, I think first we should start about variables. So we do letter find byte hello 0x a, right? Letter integer 20. That's all you really need. You could do like dd decimal, but like you really won't need anything past just an integer in assembly. Well, I guess for embedded systems you do, but why not just use C, you know? Let's see, so we got the registers. Let's do registers move EAX to 1, move EBX to 1, move ECX to 1, move EDX to 1, move, there's more. And this is only for the x86. The x86 architecture. So those are the only registers I know right now, but it'd be okay. Let's do conditionals. So compare EAX to EBX and jump to jumpy jump to jumpy, and then if else jumly. If true, else. Also, let's do and ECX is EDX, right? Or ECX equals EBX. So, and or additional statements, and this equal and this too, and then or this, and then they jump to these functions. And then tells kernel to run, or you know what I mean, to run on OS. And then what else? Conditionals, while loops. God, I'm actually a genius. I'm gonna compare, say, EAX to EBX, or EBX to 1, right? JZ, was it? What was it? Oh, what was the register? Oh my gosh, I forgot it. Or not register. Yeah, it's JZ or J. Cat. JLE. Okay. Did I literally just forget? JLZ, right? JLE. JLE, and this would be our function if it, fails. So let's do Jumbly runs this after for loop, or right, and then you put your for code, and then if not, you just jump back to Jumpy, just like that. Recursion back to Jumpy. Isn't that cool, guys? This is like the base starter pack. print statement, we do EAX into 4. Move EBX into 1. Move our letter equals of letter. Right, that's cool. We call the interrupt. And then set EAX to 1. And we call it again. So let's register to exit. Okay, so this is kind of what we got going on right now. Global start. We got our variables here. And I guess you could kind of do the same thing with the while loop, but I guess you could do like for loop. See, instead of the for loop, you do move, not EDP, move EAX to 4. Compare EAX JLE guess Jumly or exit. We should probably do this for this too. Exit and then add EAX1. Oh, I forgot to add multiply and delete. I guess you could do increment too, but so that, and then it jumps back to Jumpy or Jumly. So sets EAX to 4. It keeps adding 4 until it equals 4. 4. Set this to 0. And then you just jumbly more. Set EAX to 0. if EAX equals 4, run exit, add EAX to 1. Your code right here. Here, add 1 to EAX. Then down here, interrupt 0x80 or move XOR EAX. My brain just it just froze. EAX to 1 and then interrupt. Okay. Okay. Syntax error. Let's just comment this out. There we go. Everything works except a stupid integer. Numbers. There we go. The syntax error was a comma, so alright, I'm gonna upload this to my GitHub right now. I'm gonna leave a link in my GitHub in the description. Also do operations, so molt EAX2. Jeez,
Arithmetic instructions, variables, address modes, system calls, registers, procedures, array strings, macros. What is this? Oh, so we got macros? Oh, no way. So it's kind of like a function with parameters. It's really cool. Arithmetic, increment, decrement, adder sub. Wait, what's multiply? What's multiply? Mole? Oh, it's mole. No, I think it should work. Why can't you just multiply times 2? What would it equal after this? Divide. Where's the divide instruction? It it ran these conditionals. It ran these. It ran the these commands. So yeah, that's that. I hope you guys enjoyed this video. I learned so much. I know you guys will call me a goon for using this our makefile. Pure assembly. So cool though. What the? Okay, what time is it? It's already 4:24. It's already 4:24. All right, guys, that'll be it for today. I'll see you guys tomorrow. Bye, guys.